So basically, see guys, this is a question in which you need to draw the free body diagram of every object involved over here. है ना? M1, M2 here in this case, first case you need to draw for M1 and M2. So how will you draw? Let's start with the forces. Shall we start with the forces? Like, first of all, tell me, in this case, do you have the weight of the objects? So can you see the weight is acting over here? This will be M1G. Acha, can you see this one particular thing? Whenever I draw the weight of an object, I draw it from the center of that object, right? Yes or no? Hello? Guys, can you see this habit of drawing the center, the masses from the center of the object? This is in accordance with a concept which is
Yeah,
called as
gravity.
center of mass or center of gravity. You know, this chapter will come later on in your 11th grade physics mechanics. So first, can you see first weight is done, M1G, M2G done. Now after that, what to do? How many contact points are there? Can you see M1 is in contact with ground? So basically there will be some normal reaction on this M1 from the ground and the same normal reaction on the ground due to the block. Yes or no? So can you see one normal reaction N1 acting on this thing? Can you see at this particular point M2 and M1 are in contact? So basically this will be the direction of N2 on this block and this will be the direction of N2 on this rod. Yes or no? So can you see guys, for every action there is equal and opposite reaction. So can you see over here I'm drawing N2 N2 on both the objects. Similarly, here also this rod is placed on the ground. So can you see there is one more normal reaction N3 and this will be N3 on the. So guys, can you tell me what all forces are acting on M1? What all forces are acting on M1?
N1 and M1G and
Direction
M2G.
also. Direction also.
Downwards M1G.
M1G
Like,
vertically downwards. उसके बाद what all forces are acting on M1? On M1. So basically this, this and this. Can you see three forces are acting? Are you understanding? Can you see this N1 was acting on this block, this N2 was acting on this block, this M1G is acting on this block. So we are drawing that. Okay. So N1 in the upward direction and N2 in this direction. Yes or no? Acha, what will be this? If suppose this angle is theta, then what will be this? I told you, no, just like mg cos theta, if you remember. So N2 is acting at an angle theta. So this is the free body diagram of M1. And similarly, if I want to draw the free body diagram of M2, what all forces are acting on M2? I will draw them with, let's say, blue. So this N2 is acting on this block, this N3 is acting on this rod, this M2G is acting on this rod. So can you see the blue ones? The blue ones are acting on the rod. So if I draw the free body diagram of the rod, it will be something like M2G in the downward direction, N3 in the upward direction, vertically upwards, and there will be N2 over here. So this is your free body diagram. Any doubt? Any doubt, guys? How to draw the forces and all? समझ में आया ना? The main important factor is drawing all the forces correct. If you can draw all the forces correct, then any question on FBD can be done easily. So that's why practice those questions. That's why I'm telling you to practice these questions once again. Okay, guys. Clear, guys? Done?
Sure.
So first question is easy. Now the next question. First question has nothing new to learn. From second question onwards, we have something to learn. Hmm. So guys, what is given in the question? If there is a guy who is trying to pull this sphere with a string with a forceps. So first thing to note in this thing, if a force is
फ्री
a
बॉडी डायग्राम इसका भी करना है.
huh
फ्री बॉडी डायग्राम इसका भी करना है.
only the sphere. You need to draw the free body
There's only
diagram of the
one.
sphere.
There's force acting for the weight downwards.
हाँ वो ओपन करेंगे.
And
पहले पहले ये पॉइंट देख. पहले पॉइंट देख. हाँ चल ठीक है बता. This
so
will be
one,
mg.
yeah, and
है
then
ना.
one is at the point of contact.
So
The
basically
दूसरा,
there will be a normal reaction. Let's name it as n1. Yes
yeah,
or no?
and then one is
One
there,
normal
yeah,
reaction over here. Can you see these normal reaction n1 and n2 will pass through the center?
yeah,
I think we have already drawn this. Apart from
and
that, can you see one more force? Since I have connected with a string, so there will be a tension in the string.
so tension and yeah,
है ना?
reaction back.
Now the point is, कि sir, what to do with this F force? They have not given. Can you see the question was given? That the the man pulls the sphere with a force F. So what to do with this force F? With a force F. Will you be drawing the second force F? No. So that's why I'm writing one more point. If a force is directly applied on a string. So can you see guys? This man is pulling the string with the force F. Yes or no? Is the man pulling the string with the force F? Is the man pulling the sphere or is the man pulling the string? Hello?
So the man is pulling the string.
Anna? So if a force is directly applied on the string, then the tension developed in that string, and please remember it's an ideal string, Anna, is equal to the force with which we are pulling this. Are you getting my point, guys? So basically, you will not draw this T over here. You'll just directly draw if this man is pulling with force F, then the tension will be equal to the force F. Is this clear? Is this clear, guys?
Yes, sir.
Okay. So this was the point which we needed to talk. And now if I draw the free body diagram of the sphere, then what all forces are acting on the sphere? There is mg acting in the downward direction, yes or no? So mg acting in the downward direction. So I have drawn this mg. This mg has been drawn. Can you see this n1 acting on the sphere upward direction? Can you see this n2 acting on the sphere in that direction? So I'll draw these forces again. So n1 acting in the upward direction and n2 acting at certain angle. Yes or no? Apart from this, there is one more force which is the tension in the string. And please remember this tension will be equal to this force with which we are directly pulling the string. So either you can write T which is equals to F or you can directly write. Are you getting my point? So basically this whole question was just for this point. Tension and forces are, if you are pulling it directly, then the tension in the spring will be equal to the force with which you are pulling. Is this clear? Is this clear, guys? You understood this point, everyone?
Yes, sir.
Aman, Sania, did you understand this point?
Yes, sir.
Sorry. Acha, guys, please unmute your phone. I think Aman, Parinita, Sania, Cyril, unmute. Why
Okay,
have
sir.
you muted the phone?
Yes, sir.
Okay. So, third question now. Please do the third question now. How many objects are involved over here? 3 objects.
I'm just gonna go to the washroom real quick.
Sure, sure, sure. No problem. So there are 3 objects involved over here. What are those 3 objects? M, and the pulley, right? Here also you will learn something new. What is that something? We'll talk about later. But here also you learn something new. Chalo, start drawing all the forces acting on different objects.
M का नीचे the capital M first is down and then up. And then the small m का tension है और नीचे reaction है और weight बस.
Capital Mg on the bigger block,
Hmm.
small mg on the smaller block. Yes?
और फिर उसका tension है
The tension upwards.
and then
Pulley
the
पे,
reaction.
the pulley पे tension is downwards. The pulley पे tension is downwards. Oh, downwards and towards the left. Yes or no?
Yeah. And
And
then ये का
इस
normal
पे,
force.
okay?
Capital M का normal force.
Okay, capital M पे एक normal force, normal reaction n only, because there is only one, right?
That's it.
And this n will be acting down. Now,
Yeah.
when you will be drawing the free body diagram
So
of,
N acting downwards is
because block pushing the ground downwards. This small n is acting on the ground.
That's weight only, na, basically.
Nah. Weight and normal reaction are different things. It's not necessary weight and normal reaction are always equal. Okay? Okay?
Yes.
So FBD of small m. When you will draw the FBD of small m, I am not telling you to draw whether it is accelerating upwards or downwards. No, I'm not talking about the motion. I just want you to draw the forces. That's it. So now see this thing M. When this tension small mg is acting downwards and tension T is acting upwards. Okay? Is this the small FBD of small m? Yes or no, guys? Is this the small free body diagram of small m? Now let's talk about the free body diagram of capital M. Capital M पे there is capital Mg acting downwards, the weight. There is a normal reaction acting upwards. Is there any other force acting on this? Then obviously your answer will be no, right?
Yeah, no.
Wrong. यहाँ पे ये चीज wrong हो जाती है. So what next point is there in a body, free body diagram? See over here.
That's the correct answer, no? ये free body.
Huh? No, that is not the correct answer. That is not the correct answer. I am just, availing some space for.
ID को wrong then.
Huh?
Third वाला correct है free body?
नहीं अभी नहीं हुआ. अभी बनाएंगे. Wait, no. We are making it. Why isn't it going now? So this thing becomes wrong. And why does this thing become wrong? Can you see this pulley? Can you see this pulley? Is directly connected. Is the pulley directly connected through a rigid support on the block? On block capital M? Yes or no? Yes or no, guys?
Yes, sir.
अब देखो, these two forces are acting on the pulley, right? The two tensions T and T are acting on the pulley, right?
They'll cancel each other out.
No, they can't cancel each other. They are acting in different directions. Can you see one acting at 90 degree? If they would have been acting at 180 degree, then they would have cancelled out their effect. But can you see the tension are acting at 90 degree? So basically these two tensions will try to push the pulley with a force of root 2t in this direction. Why root 2t? Because can you see two equal forces at 90-degree angle? So the resultant of this t and this t will try to push the block in this direction. So the block will also try to push the pulley away. Yes or no? Yes or no, guys? So
Yes,
can you
sir.
see this tension which is acting on the pulley is trying to push the block. So basically we didn't consider this root 2t because of this pulley. Are you getting my point? So always remember one more note. When any element like pulley or what do I small block fixed will do this thing on the given block.
So why is the force pushing it downwards?
Because इन दोनों का resultant देखना, suppose एक तरफ से someone is trying to pull you towards right and one way someone is trying to pull you towards down. तो तेरे पे जो force लगेगी उन दोनों का resultant क्या long लगेगी?
Yes, sir.
That's why we are considering. So when any element, a pulley or a small block fixed on the given
Back,
block is
sir.
that. Yes, tell me. Hello. Okay. Now Cyril is you are back. So Cyril, we
Yes.
are learning this thing. See, whenever you have any block, any element, can you see this pulley is directly attached to this capital M
Yes.
block? So we are learning this thing. So
Yep.
whenever this there is any element which is directly connected to any block. So when any element is directly connected to a block, then the force acting on the element, then the forces acting on the element are directly considered directly to be applied on the given block. So basically, what do you mean by this statement? Once you write it, then
So
tell
if
me.
M is connected to a pulley and it is directly connected to capital M, the force applied on M small will be
Not
will
small
be
m.
direct.
Can you see the M is not connected directly? If I would have taken a rigid support and connected M and M over here like this, then I would have said कि M is directly connected to this thing. But no, है ना? Don't worry, ये concept भी आएगा. So this FBD which you have drawn, where you have just considered this N and this Mg is wrong. You need to consider these two tensions as well, because these two tensions are acting on the pulley which is directly connected to capital M. Okay, so basically if you draw the correct free body diagram, the correct FBD would look like one tension also coming down and one tension going towards. So this is the correct free body diagram. Can you see these two things, these two tensions? They were acting on the pulley.
Same axis, right?
Huh?
They're not on the same axis.
I'm not drawn on the same axis. Can you see T was acting vertically downwards in the direction of mg? So see T and mg were vertically downwards. Whereas this capital T was towards the left, so we draw towards left. Okay. When I was preparing for my JE and all, nobody gave me this point. Huh?
So shouldn't it be root 2G?
Root 2G, nahi, root 2T. Root 2T. So either you can draw that root 2T, but that root 2T will come ultimately out of the frame. So you'll break it into two components again. So what's the point? Let it be T and T.
Sir, and one more thing. What is the statement? Because this is capital M is not directly connected to
Small m. Capital M is directly connected to this pulley. So whatever forces which are acting on the pulley will be considered to be acting directly on M. So when we are drawing the free body diagram of M, that is why we included these two tensions
but those
in
forces
the.
will also act on small m, right?
हाँ तो this T is acting on small m. Can you see this tension is acting on small m? Are you getting my point?
Yeah. The upwards and downwards only.
हाँ, so I'll draw it with a different color. The tension and mg which is acting on small m is marked with blue. So can you see this T and this mg is acting on small m, but all the one which are with black are acting on the capital. Is this clear, Sani? Any doubt?
No, sir.
Did you write down this note?
तो फेयर एंड लवली का नाम ग्लो एंड लवली हो गया
ऐसा कुछ नहीं है.
सर न्यूज में आ रहा है दे चेंज द नेम
It was because of racism or something like that.
Yes, sir.
Okay.
So Black Lives Matter.
Yeah. Every life matters. It's not like Black Lives Matter.
Yeah.
नहीं सर but
No,
like
because of that only they changed.
सर but blacks are getting discriminated ना तो अभी हम सब बात थोड़ी ना करें अगर दो घर एक घर जल रहा है तो पानी थोड़ी ना दूसरे घर में डालेंगे
सही बात, एकदम सही बात, करेक्ट.
That's why this is black. इससे लोगों को समझ ही नहीं आ रहा
अभी सब लोगों का ना जो ब्लैक लाइव वाला है उधर पानी डालना है, फिर वो बुझ जाएगा, उसके बाद फिर सब जगह पानी डालेंगे ना.
हाँ
नहीं ठीक है, अभी चल रहा है, इट्स थिंग गोइंग ऑन, सो इट्स गुड. Yes, guys, are you done with writing the note? So did you understand? We learned two different things over here. First thing is if you are applying a force directly on a string, so that force is acting as the tension in the string, right? The second thing which we learned is if there is a thing which is directly connected to a block, and whatever forces are acting on the block, that will be acting as what? Is it clear? Chalo. The next one. This is, I can give this as a homework to you people, because this is now you can understand. So this is I'm giving as a homework. Chale. Now guys, write down a heading. Motion of connected bodies. Okay, or basically suppose this is a type, na? This is a type of question, very important type, as you know, for considering this NLM and all. So suppose guys there is a smooth horizontal ground. Can you see a smooth horizontal ground? And I have 2 or 3 blocks. Okay. So Control C, Control V, Control V, Control Z. Control V. So guys, can you see 3 blocks which are placed on a smooth horizontal ground? Yes or no?
Yes.
Now suppose all these 3 blocks are connected with a string not a string with, basically, can you see this is a different string between this block and this block? This is a different string which is in between this block and this block. Yes or no? So all the blocks have been connected with each other with the help of a string. This is block A, this is block B, this
Please
is
show me
block
the fourth one, sir.
Huh?
Fourth वाला.
Fourth वाला,
साथ में कुछ लिखा नहीं.
नहीं, this is I gave you the homework. सब चीजें मैं बता दूं. इसमें भी यही point. Can you see the same point? The tension which is acting on this pulley, and you'll be drawing the tension on these two pulleys. This pulleys, right? So these two tension TT will be involved in the free body diagram of this capital M. Okay. Okay. अरे हाँ है ना?
Yes sir. हाँ.
These tensions should be included in FBD of capital M. Okay, so this is what I was saying. So that's why I gave this as a homework, because we already discussed that point. So you will be applying that one. Now suppose, guys, I have three blocks A, B, C. This is mass M1, this has a mass M2, and this has a mass M3. Can you see? I am pulling all these blocks. I am pulling with a force A on this block F, right? Yes or no, guys?
No.
So now the question is, if all of them is placed on a smooth horizontal floor, then tell me, what will be, question is to find the tension in each string and the acceleration of the velocity. Ganesh, is this the question type which you were saying? Acceleration of body?
Find the tension in each string and the acceleration.
And is this the thing which you are saying? This is your string one.
हाँ, मैंने ऐसे क्वेश्चन पूछा है.
So you only said no, sir. We in the school we discussed. We had this some question
Oh
like this.
yeah, motion of horizontal, something like that.
Was this the type?
Yeah.
So basically, guys, first thing, what is the direction of tension? If these strings are tied, then can you tell me the direction of tension? Let's say the tension in the string one is T1. So will this be the direction of T1, and will this be the direction of T1? Yes or no? For this point will be the support, and for this point will be the support, right? Similarly, here this will be T2, and this will also be T2. Yes or no, guys? Yes or no? Now, let us say the normal reaction from ground on the first block is N1. So here there is M1G, weight and normal reaction. The normal reaction acting upward, weight acting downward. Normal reaction acting upward, weight acting downward. Yes or no, guys? Any doubt in this, guys?
No, sir.
So we know this particular thing is, are the blocks flying up? Are the blocks flying up? Hello? Are the blocks flying in the air, or are they digging into the ground? No, na. So hence they are at rest in the vertical direction, right? So N1 will be equals to M1G, N2 will be equals to M2G, and N3 will be equals to M3G. There are these three equations which we don't require as of now. Okay, but still I am telling you at least these equations, they exist. Okay, now only see the horizontal motion. Only see the horizontal motion. Let us say this block goes with an acceleration A. Right? Guys,
Yeah, yes sir.
if I say block A,
this cross block,
I don't require these equations. So in spite of writing across, I'll write not needed as of now. Right? So now see guys over here, if I say this block A is moving with an acceleration A in this direction of force, so what will be the acceleration of this block? If this spring is inextensible, so will this spring also has to move with an acceleration? Yes or no? If both the blocks they move in the same direction with the same acceleration, then only the length of the string will remain constant, right? Yes or no?
Yes, sir.
Similarly, the same concept will be applied on this thing as well. है ना? So for the strings to be unstretched, the acceleration of all the blocks should be same in this case. The acceleration of all the blocks should be same in this case. Yes or no?
For the strings to be unstretched, the acceleration. Yeah.
So can I say this particular thing? All the blocks they are moving with the same common acceleration. Now
But
can
they
you?
should start from a rest.
So now if I draw M1 FBD of block A, FBD of block B, and FBD of block C. So will it be like when I can you see when I draw the free body diagram of block A, what all forces are acting on block A? Can you see four forces N1, M1G, F and T1? I will be not drawing N1 and M1G, okay? Is it fine? I don't need the vertical direction as of now, so I'll be just drawing the forces which are acting in the horizontal direction. So on the block of mass M1, this F1 is F is acting towards right, and T1 is acting towards left. Can you see over here? T1 acting towards left and F acting towards right. Yes or no? Yes or no, guys? And this object is going with an acceleration. What is the acceleration of this object? A, right? Similarly, if I draw a free body diagram of B, acha, first draw the diagram, otherwise you will be confused. Draw the diagram, draw the forces.
So could you scroll down, sir?
Is the free body diagram of A any doubt? I'm not drawing
The tension
N1
one
and
should be
M1G. Huh?
right?
Yeah?
The tension one should be equal to the force applied on the body.
Yes. No, 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 no. Tension one देख कौन सी string में? Am I applying tension one in that string?
So could you scroll down, sir? The tension one should be equal to the force.
Mm-hmm. Can you see tension one is acting towards left?
Uh,
If I have a string over here, which I'm pulling with a force F, so tension in this string will be F. Okay?
for the body 2, the tension 1 will be equal to F.
For the body B, T1 will be equals to F. ऐसा are you saying?
Yeah.
No, it won't be equal to F. It will be just T1 only. It will be just T1 and just T2. मन से कैसे ले सकते हैं?
उसका फायदा क्या होगा?
फायदा ही बताऊंगा ना थोड़ी देर में. ये देख ये T1 और ये T2. We are just drawing all the forces which are acting. So can you see T1 and T2 which were acting on this block B? I have drawn them.
Yes, sir.
And this is going in this direction with an acceleration. Now what about C? On C there is only this T2 which is acting towards right. So can you see this T2? So only this T2 is moving the object towards. Okay. Is this clear? Huh?
I'll get it back.
Get it back what?
चल मैं अभी 1 सेकंड में आता हूँ.
Ah, ठीक है. Okay. So is this clear, guys? Is the free body diagram clear? Now can you see if the object is accelerating towards right, then can I say F minus T1 is equals to M1 into A? Can you see if the object is accelerating towards right? So can you see T1 should be greater than T2? So T1 minus T2 should be greater than equals to M2. And there is only one force T2 over here, so T2 is equals to M. Yes or no? Is this equation clear? Guys, are these equations clear to you? Yes, Aman, how did we obtain the first equation?
So the FBD of A.
But can you explain me?
So the force was in the right direction, but then the opposing tension, which was T1 from the force string, was in the opposite direction. So we just subtracted that and equated it to M1A.
But why did we subtract it?
So because they're in opposite directions.
So to find out the
Net force.
we subtracted it. Okay. And why did you say F minus T1? Why not T1 minus F?
So because the object is moving in the right direction.
The object is accelerating in the right direction, so hence F has to be bigger as T. I know.
Yeah,
Perfect.
F is great. That's what I'm saying.
Yes. So that's why we made this first equation. Sanya, can you explain me the second equation, please?
Yes, sir. So T1 minus T2 is equal to M2 into A. So what's there to explain? Like.
No, but I want you to explain how did you get this equation? Just like Aman did.
I don't know. So, oh yeah, last time we studied the fifth ka B part.
Exactly, the fifth ka B part. That is fifth ka B part. We made this equation according to fifth ka B part.
Yes,
since
sir.
the object was accelerating towards right, so hence T1 has to be greater than T2. Hence T1 minus T2 is the net force. As it is equals to mass multiplied by action. Cyril, third part, can you explain the third equation? Hello, Cyril. Yeah, can you explain the third equation to me? This one, T2 equals to M3A.
Sir, I don't understand it.
Acha, Nicolin, can you explain this thing?
So can I explain it?
No. So Nicolin, क्या?
Sir?
Can you explain the third equation? This one, third, last. Can you explain this? How did I get this equation?
No, sir.
Huh?
Sir, I'm not sure.
Arey, so whatever, tell me now. What do you know? How did I get this equation? How much did you understand? That's what I want to see. Batai. See, I'll explain it to you again. See this, there was only one force which was acting towards the right from the, when you draw all the forces and all, so you saw here on the C block, there is only one T2 which is acting towards the right, and that is mainly responsible for acceleration. So since there was no one to oppose this T2, can you see there is nothing towards left, right? So hence T2 is equals to M3 into A. Why? Because the net force is equals to this single force only, right? There is only one force, so hence the net force is this T2, and this is providing the mass into acceleration. So fifth the B part we applied again, and we got all these equations. Once you got all these equations, what to do now? Add all these. Why do you want to add all these? Can you see this is minus T2, this is plus T2. So on adding, this will get cancelled. Can you see this is minus T1, this is plus T1. On adding, it will get cancelled, right? So on adding 1, 2, and 3, we will get F minus T1 plus T1 minus T2 plus T2 is equals to M1 plus M2 plus M3 into it. Yes or no? So can you see from here, guys? The acceleration will be only F will remain over here. So the acceleration of the blocks is equals to F upon M1 plus M2 plus. Is that clear? Is this clear, guys? Acceleration.
Um, and yeah.
Sir, can I leave?
Sure.
Thank you, sir.
So guys, since there were this particular thing, can you see there were three blocks M1, M2 and M3 and you were applying a single force F on this. So what can we do? We can assume the whole system. Can you see this was also moving with acceleration A, this was moving with acceleration A, this was also moving with acceleration A. So you can assume that there is just one common block of mass M1 plus M2 plus M3 which is moving with a force F and same acceleration. Is this clear? So you can assume this when only a single force is there and this is kind of clear. So now you got the acceleration. Now what to do?
Sure, that's it.
ना acceleration के बाद tension भी तो निकालना है. I told you to find out the tension in the strings. Yes? Yes or no? How will we find out the tension in the strings? We'll just put the values of, we got the values of A, right? So do you remember from the third equation, T2 is equals to M3 into A? Yes or no? So we just put the value of A over here. So this will be equals to M3 upon, what is A? A is equals to F upon M1 plus M2 plus. Put it over here, it will become something like this. Will this be the value of your T2? Yes or no, guys? M3 multiplied by A. Let this be it. Guys, please remember these are not formulas. These are just your questions. The formula is only one. F net is equals to Ma. That's it. Similarly, when I solve this now, T1 minus T2 is equals to M2F. Can you see from equation number 2? So I can have T1 is equals to T2 plus M2 into F. So which will be equals to, what is T2? T2 is M3 into F upon M1 plus M2 plus M3 plus this will be M2 into A will be equals to this. So can you see from here guys? T1 will be equals to M2 plus M3 given to F upon M1 plus M2. Sir, we need to memorize these formulas or not? No, there is no need to memorize this. There is a trick to remember this. है ना? So once you are done writing, then I'll tell you the trick.
सर
Yes.
तो मैंने आज शेव किया.
क्या बात है? चल वीडियो चालू
हाँ.
कर दो.
नहीं नहीं नहीं.
So guys, whenever you're done, just tell me. I'll give you a trick to solve this type of question directly. Okay?
So how is T2 equals to M3A?
How is T2 equals to M3A? By equation number 3 from here.
Oh yeah, yeah.
Guys, did you understand how to solve these type of questions? Just to draw the free body diagram. Once you're done with the free body diagrams, then motion of connected bodies on a horizontal floor, smooth horizontal floor. Whenever it is a smooth horizontal floor, then how will you do? Suppose guys, there is this M1, M2, M3, and let's say there is one more M4. There are how many strings are there? 3 strings are there, na? So let's say this is your string 1. Tension is T1. This is your string 2. Tension is T2.
पहला वाला example, it was in a smooth surface.
It was a smooth surface. Abhi we are not talking about friction as of now. Enough?
Yes, sir.
So let's say this is T3. This is your M1, this is M2, this is M3, this is M4, and I'm applying the force in this direction. Okay. So if someone tells you what will be the acceleration of the block, so acceleration will be equal to what? The force divided by, since we know this particular thing, all of them will move with the same acceleration, hence the total mass. So acceleration ke liye, I think you don't require my help, right? You will assume this as a common system, and yes or no, guys?
Yeah, we know it.
Now if I want to find out tension in the string 1, okay, tension in string 1, then can you see I break it from here, break the circuit from here. So can you see this M1 is with F and the remaining mass? What is the remaining mass? Can you see you break it in the direction opposite to the applied force? Can you see M2, M3 and M4? So M2, M3 and M4 divided by the total mass, M1 plus M2 plus M3 plus M4 multiplied by. This is your T1. Similarly, can you solve for T2? Can you see when it will be T2, then you will break it from here, right? When you will break it from here, then what are the blocks which are following this thing? M3 and M4, right? Can you see in the direction opposite to force? So M3 plus M4 divided by M1 plus M2 plus M3 plus M4. multiplied by. Last part, what is the tension in the string 3? So can you see if I break it from here, what is the one which is following it? M4, right? So T3 will be equals to M4 upon M1 plus M2 plus M3 plus. Are you getting my point, guys? So basically, always see the direct, then see the total sum of the blocks which is after that string. See the total sum of the blocks. Just for example, string 1. Which blocks is the string pulling? Guys, tell me, which blocks is the string 1 pulling? Is string 1 pulling M2 plus M3 plus M4? Yes or no? Hello? Is string 1 pulling the weight of all these three? Or not the weight of all these three? Is string 1 pulling all these three blocks, right? M2, M3 and M4? Yes or no? Hello?
Yes, sir.
So string 1 is pulling M2, M3, M4. So see, we wrote in the numerator M2, M3, M4 and just multiplied with F and this. Similarly, string 2 was pulling only M3 and M4. So only M3 and M4. String 3 is pulling only M4, only M4. So this is a trick to, remember this. But please remember, this is only valid for smooth horizontal surface. If you make it incline or something like that, it won't work. Okay?
Yes, sir.
Please write it. Guys, are you done writing? Guys, are you done writing? Shall I give you one question which is based on this concept?
Yes, sir.
Uh, an engine of a small train has a mass So there is a train which consists of engine and the mass of the engine has 4000 kg. Now the question is, if the train consists of one engine and four wagons,
Hey Siri, switch off the Bluetooth.
the train consists of one engine and three wagons. Then find out.
So Bluetooth वो बहुत ज़्यादा बैटरी खाता है.
Yeah. Then find out the force applied by the first wagon after the engine on the second wagon. So basically, can you see the question is just similar to that blocks and all, right? Also, the engine pulls with a force ten to the power 5 newtons. Find it, please. First, it's a question based on what you have just learned. Draw the diagram best. Okay, and just give me 2 minutes. I'll be just back. Chalo, hello. Answer आया? Guys, did you get the answer? See, this is the engine. This is the force with which it is pulling. Let's say, how much is the force? 10 to the power 5. Okay. And on this engine, there are how many wagons are there? 3 wagons are there, right? Yes or no, guys? This is the first wagon, this is the second wagon, and this is the third wagon. What are they asking? Find the force with which the first wagon applies on the second wagon. Matlab basically they are asking you this force, right? Force over here. So you can understand this as like string 2, string 1, string 2, string 3, right? So what will be this force? Direct formula, F is equals to. Acha, when this question will come in school, you need to do exactly like this, na? Drawing the free body diagram and then solving. Otherwise, in competitive, you can solve it directly. And don't worry, in school exam, they will not give you more than 2 blocks. That's the maximum they can give with first and second. So how will you find it out directly? What is the mass after this? Can you see this and this? So what is the mass of this?
So 4,000.
4,000 was engine.
2,000, sir.
So 2,000 was wagon, 2,000 here, and 2,000 over here. So basically, what is the total mass after this string? It is 2,000 plus 2,000, which is 4,000, divided by what is the total mass? 4,000 plus 2,000 plus 2,000 plus 2,000.
9,000.
Arey, 4
अरे
plus 6
9
9 होता है क्या?
6 plus 2 plus 2.
4 plus 6 is how much, Tanish?
Yeah, sorry sir.
So this will cancel out with this one will cancel out with this. So what is the answer? 4 into 10 to the power 4, which is basically 40,000 Newton. And that is the force which the first wagon pulls the second. Is this clear? This
Yes, sir.
is the answer to your question. Simple. Yes. Shall I give you one more question?
नहीं
हाँ.
sir, please break sir, jaldi break sir.
नहीं नहीं नहीं
Yes, sir.
Only
Please, please.
10
Sir. It's been a
only-
long time.
La-
You've not given a break.
last
Sir, मजा आ
question.
जाता.
Last question, and then I'm leaving. No problem. This type will be over. I'll give you some, same type, but on inclined plane next time. A rope of a mass 5 kg has a length of 1 meter. Can you see the rope is not identical? Okay. The rope of mass 5 kg has a length of 1 meter, is pulled on a smooth horizontal surface, on a smooth horizontal surface. And please remember, a uniform rope of mass 5 kg has a length of 1 meter, is pulled on a smooth horizontal surface with a force of 100 Newton. Find the tension at a point 20 centimeter from the other end of application of force. Basically, what are they asking? Suppose if this is a uniform rope of mass 5 kg and this force is pulled with a 100 Newton force. So they are asking from the other end, what is the tension at a point 20 centimeter from the other end? So how will you do this question? Have I taught you how to deal with ropes of having ropes having certain mass?
No sir.
So how to do this thing now? See, this is again the same thing as, can you see the word uniform written over here? What do you mean by a uniform rope? That is, the mass is distributed uniformly over the rod, right? Yes or no?
Yes sir.
So what you can do, if it is a uniform rope, then you can convert it into two different parts. You can say, I'll cut the rope over here. When you'll cut the rope over here, this will be one part and this will be another part. Okay. Connect them with a string. Tell me this particular thing, if this whole thing is 1 meter, that is 100 centimeter, 100 centimeter. So what will be this much length? 80 centimeter, right? Yes or no? So basically what you can do is just say that, sir, I have cut 20 centimeter, that is the 1/5 part. 1/5 part of the rope. Is this the 1/5 part of the rope? Yes or no? And is this the 4/5 of the rope? Yes or no, guys?
Yes sir.
So can anyone tell me what is the mass of this? What just happened? Can anyone tell me what is the mass of 4/5 of the rope? So 4 by 5 of 5 kg, it will be 4 kg. So can you see this thing is 4 kg? And what will be this? Yes or no? Can you say like this? Since it is uniform, you can do this. Now, this becomes exactly the same question which we are discussing. So what is the tension at this particular point? So the tension at point A at the given point, will it be equals to 1 divided by 5? 1 divided by 5 cube, 1 divided by 1 plus 4 multiplied by. So will it be equals to 100 divided by 5, or basically your answer will be 20 Newton, right? Is this clear, guys?
Yes, sir.
Understood? You know this, how to convert this to this, then this, applying the concept which we have learned. So this is your application. In the next class, I'll give you some more questions which are based on the motion of connected bodies. In one type of the question, I'll include a force over here. In one type, I'll give it on a inclined plane, smooth inclined plane, and then we'll see how you are able to do that question.
So
Okay.
khatam.
Bas. So these are the two questions which are left. We'll do those two questions in the next class, and we'll be done with the motion of a connected object. Then we'll see what happens when there are many varieties of different types of questions which can be found. So we'll do those as well. Enough?
Thank you, sir.
What is your homework, guys? Your homework is to see the questions, whatever questions we are discussing in a day, see those questions once you start revising at home. So see those questions. That will improve your concept and your understanding on free body diagram. Is this clear?
Yeah.
Chalo. Okay. We'll see you again in the next class. Thank you very much.
Thank you, sir.
Okay. Chalo.
Thank you,
Thank you,
sir.
sir.
Okay.
Bye bye.
Bye bye.